G'day, Mr. Bennett here. Now today we're going to be looking at the atom itself, and we've already seen some stuff in our previous topic. So remember we were talking about the energy shells, or the atomic, the absorption spectrum and the line emission spectrums is due to the electrons, okay, and the transitions of the electrons in the electron shell, and that gives the characteristic colours or the line emission and absorption spectrums that we see for each particular atom. Now we're going to be going deeper and looking at the concept of the nucleus itself, right? So just some terminology that you would be aware of, but you need to definitely know, is for an atom we have these things called protons, and we have neutrons, right? So they're in the nucleus, and we call these nucleons. Okay, so we call them nucleons, and they're in the nucleus, alright? And then we have obviously electrons as well. Alright, now symbols that we will use for an element, we'll have the A and we'll have the Z, alright? Or it could be also equal to, or we might see it written as A and Z depending on how the terminology goes. A is equal to the atomic mass number, and that's equal to the number of neutrons plus the number of protons. These are things that you need to know, and Z is the atomic number. The atomic number, and that's equal to, when we start looking at it, that's actually equal to the number of electrons, which is equal to the number of protons, which is actually quite interesting when you start thinking about that. Alright, so that's the first thing, the terminology you must know, and I'm pretty sure most of you have seen that before. So if we were looking at something like nitrogen, nitrogen has an atomic number of 7, and it has a mass number of 14. So that means that's got 7 electrons, it's got 7 protons, therefore it must have 7 neutrons. So you can actually work out the number there. Right, if we had something like carbon, carbon's got 6 electrons, it's got 6 protons, and it's got 6 neutrons. Then when we start looking at something like uranium-234, that's going to have 92 electrons, 92 protons, and then it's going to have 234 take 92, which is going to give you 142 neutrons. So there's a lot more neutrons with the heavier massed atoms themselves. Right, so that's the process that we need to understand and look at when we start looking at the atoms themselves. Right, so you need to be able to identify those. So if you get any of those sort of questions in a test or an exam, you'll go, yay, this is easy, I can do this. Now, another term that you need to understand is a thing called an isotope. Right, so an isotope is an element with the same atomic number but different mass number. Alright, so that's what happens with the isotope. In other words, it's got more or less neutrons. That's basically what you're looking at. So just an example, a very simple one, when we do carbon dating and that, there is carbon 12, which has got 6 electrons. If it doesn't have 6 electrons, 6 protons, it's no longer carbon, it'll be something else. And then you've got carbon 14. Okay, so just to talk about that very briefly, when you start looking at carbon, naturally occurring is both carbon 12 and carbon 14. in anything that's organic, they'll have a mixture of those things, because carbon-14 is in the atmosphere, and so anything that's organic that takes in air will have a ratio of carbon-12, carbon-14. When something dies, though, it's no longer bringing carbon-14 in, and if you know the half-life of carbon-14, then if you can work out how many half-lives it's actually done, then you have a way of working out how old something is. So that's what carbon dating is all about. Alright, so that's the first thing there. The other isotopes that you will be looking at is uranium-92 to 34, uranium-92 to 35. Okay, just two forms of uranium, and again they both have 92 electrons and protons. They just have a different number of neutrons. Alright, so that's a really, really important part of what we'll be talking about when we start talking about radioactivity. The isotopes is an important part of that. Alright, so in terms of looking at equations, it's really important that we know that we have to balance the atomic mass and the atomic number. Alright, so in terms of when we do calculations for that, we need to be able to identify some of those. Alright, and I'll go through some of those in our next video. Alright, so this is just a very, very brief introduction, and we'll look at some equations where we use these concepts in our next one.